हेलो स्टूडेंट्स, केमिकल बॉन्डिंग में आज हम मॉलिक्यूलर ऑर्बिटल थ्योरी डिस्कस करेंगे। मॉलिक्यूलर ऑर्बिटल थ्योरी जो है, दिस थ्योरी इज़ गिवन बाय होन्स एंड मुलिकन। होन्स एंड मुलिकन। This theory is given by Hones and Mulliken in 1932. ये थ्योरी जो है, इसकी नीड क्यों पड़ी? क्योंकि जो वैलेंस बॉन्ड थ्योरी थी उसमें बहुत सारे लिमिटेशंस थे, बहुत सारे डिफेक्ट्स थे। डिफेक्ट्स इन वीबीटी, जिसकी वजह से मॉलिक्यूलर ऑर्बिटल थ्योरी का नीड पड़ा। तो वीबीटी के क्या क्या लिमिटेशंस थे? जो वैलेंस बॉन्ड थ्योरी थी, it do not explain molecular orbital, do not explain molecular orbital. VBT do not explain stability of hydrogen molecule, stability of hydrogen molecule, right? VBT, it do not explain paramagnetic effect, paramagnetic effect of molecules and this VBT, it also do not explain diamagnetic effect of diamagnetic effect of molecules. So to overcome these limitations, molecular orbital theory takes birth, right? So the molecular orbital theory, it explain the certain characteristics of molecules like bond order, bond length, diamagnetic effect, like stability, and paramagnetic effect of the molecule, right? So VBT was not able to explain if we have H2 molecule, H2 positive, H2 negative, right? VBT was not able to explain the stability. VBT do not explain the stability of this, right? It was explained by molecular orbital theory. So first of all, we will study the main points or postulates of the molecular orbital theory. Main points. So what are the main points or postulates of the valence bond theory? So first point is atomic orbitals. Atomic orbitals combine to form molecular orbitals. फर्स्ट पॉइंट है कि एटॉमिक ऑर्बिटल्स कंबाइन करके मॉलिक्यूलर ऑर्बिटल्स बनते हैं. सपोज दिस इज हाइड्रोजन, व्हेन दीज combine they will form H2. Molecular orbital says this is the atomic orbital of hydrogen, this is another atomic orbital of hydrogen. When these two atomic orbitals combine, they will form these two molecular orbitals, right? These both are molecular orbitals, MO, right? So what is next after this? Molecular orbital theory says after combination of atomic orbitals, right? After combination atomic orbitals lose their identity. Second postulate क्या है बच्चे? Number of molecular orbitals formed is equal to number of atomic orbitals combined. Atomic orbitals combined, right? कितने मॉलिक्यूलर ऑर्बिटल फॉर्म होंगे? जितने एटॉमिक ऑर्बिटल्स कंबाइन होंगे, राइट? अगर हमारे पास 2 एटॉमिक ऑर्बिटल्स कंबाइन होंगे, सो वी विल गेट 2 मॉलिक्यूलर ऑर्बिटल्स. अगर 6 एटॉमिक ऑर्बिटल्स कंबाइन होंगे, सो वी विल गेट 6 मॉलिक्यूलर ऑर्बिटल्स. नाउ third postulate, only those atomic orbitals form molecular orbital which have comparable energies. Only those atomic orbitals form molecular orbitals which have comparable energy, which have comparable energy। सिर्फ वो ही एटॉमिक ऑर्बिटल मॉलिक्यूलर ऑर्बिटल बनाएंगे जिनका कंपेरेबल एनर्जी होगा, जिन एटॉमिक ऑर्बिटल्स का कंपेरेबल एनर्जी होगा, नियरली इक्वल, सेम एनर्जी। सपोज दिस इज 1s orbital, when it will combine with another 1s orbital they will form molecular orbitals, right? These are the molecular orbitals, and these are atomic orbitals which have same energy, right? 1s and 2s will never combine because they have much energy difference. They will never combine because they have much energy difference. Much energy difference. Okay. Next postulate: when atomic orbitals combine, when atomic orbitals combine, they form two types of molecular orbitals. They form two types of molecular orbitals, right? One molecular orbital will be bonding molecular orbital and another will be anti-bonding molecular orbital. This is the bonding molecular orbital and this is anti-bonding molecular orbital, right? This has lower energy and this has higher energy, right? So for the combination of atomic orbitals to form molecular orbitals, we have certain rules to fill the electron in molecular orbitals, right? So next postulate is for filling of electrons in molecular orbitals, right? The following principles should be followed. The following principles should be followed, right? First principle is of Bohr's principle. Of Bohr's principle. Electrons are filled in increasing order of their energies. Electrons are filled in increasing order of their energies. Next is Pauli's exclusion principle. Pauli's exclusion principle says no two electrons in an atom can have same value of of 4 quantum numbers. चारों के चारों क्वांटम नंबर्स की वैल्यू सेम नहीं हो सकती। और पॉली एक्सक्लूजन प्रिंसिपल को ऐसे भी डिफाइन किया जा सकता है कि एन ऑर्बिटल कैन अकोमोडेट मैक्सिमम ऑफ 2 इलेक्ट्रॉन्स इन ऑपोजिट स्पिन। कोई ऑर्बिटल है तो ऑर्बिटल के अंदर मैक्सिमम से मैक्सिमम 2 ही इलेक्ट्रॉन आएंगे विद ऑपोजिट स्पिन, राइट। नेक्स्ट रूल जो है मॉलिक्यूलर ऑर्बिटल्स के अंदर इलेक्ट्रॉन फिल करने का, दैट इज़ दी हुन्स रूल ऑफ मैक्सिमम मल्टीप्लिसिटी। सो हुन्स रूल ये कहता है कि pairing of electron in an orbital will not take place until each orbital gets 1 electron each, right? So these are some of the postulates of molecular orbital theory. Now what is molecular orbital theory, right? So we can say molecular orbital theory explains some of the characteristics of molecules like bond length, bond energy, paramagnetic effect, diamagnetic effect of the molecules. Now for the formation of molecular orbitals, linear combination of atomic orbitals takes place. In short, we can write as LCAO, linear combination of atomic orbitals. According to molecular orbital theory, the molecular orbitals are formed by the linear combination of atomic orbitals of the atoms, right, which form molecule. linear combination means simply the addition or subtraction of the wave function of the atomic orbitals. Linear combination means the addition or subtraction of wave function, right, of the atomic orbitals, right. For example, consider two hydrogen atoms, one is labeled as HA and other is labeled as HB, right. Let the wave functions for the electrons for the electrons of atomic orbitals in HA equivalent to psi A and HB equivalent to psi B, right. When these two atomic orbitals are brought close to each other, they combine to form molecular orbital, right. And if the linear combination of the atomic orbitals takes place, then we can write the molecular orbital of the wave function is written as wave function A plus minus wave function of B, right. So in terms of molecular orbital theory, if the addition takes place, then molecular orbital will be equivalent to psi A plus psi B, right, for the addition. And if the subtraction, then molecular orbital wave function equivalent to psi A minus psi B, right. Now in molecular orbital theory, these two molecular orbitals are represented by sigma and sigma star. Sigma is for bonding molecular orbital and it will be given by wave function of A plus wave function of B, and sigma star for the anti-bonding molecular orbital and it will be given by wave function of A minus wave function of B, right. So the orbitals associated with psi are the orbitals which are called the bonding molecular orbitals, right. we will write as psi equivalent to psi A plus psi B. It is for bonding molecular orbital. And anti-bonding molecular orbital we will represent as psi star equivalent to psi A minus psi B, right? It is for anti-bonding molecular orbital, right? Now, how a combination of molecular orbital takes place, let us proceed further. Suppose we have this 1s orbital, this is another 1s orbital, right? When these two orbitals combine, they will combine in this way, right? And finally, by addition, they will form this type of molecular orbital, and addition is for bonding molecular orbital. It will be represented by sigma 1s, right? And if we have 1s orbital subtracted another 1s orbital, right? When they will combine, we have node in this region, right? And how the molecular orbital will form, it will form in this way, right? And we will represent sigma star 1s, right? If this is plus, this is plus, so it will be plus and it will be minus and it will be positive, it will be negative, right? By subtraction, anti-bonding molecular orbital form, and by addition, bonding molecular orbital form, right? Now, if we have the combination of 2p atomic orbitals, then how the combination takes place? This is one p orbital, this is another p orbital, right? Suppose this is positive lobe, this is negative, this is positive, this is negative. When they combine, they will combine in this way, and finally by the addition they will form the bonding molecular orbital. And how they will form bonding molecular orbital? They will form in this way, right? This bigger lobe will be positive and these two smaller lobes will be negative. Suppose this is 2pz, right? And finally we will get sigma 2pz. If we have subtraction, if we have this subtraction of these two p orbitals, right? Positive lobe, negative, positive lobe, negative. So how the combination takes place, and finally we will get the anti-bonding molecular orbital in this way, right? this will be positive, negative, negative, positive, right? And this will be sigma star 2pz, right? If we have parallel overlapping, right, parallel overlapping, so in parallel overlapping, finally the bonding molecular orbital will be formed in this way, negative electron density and positive, right? And this will be pi. Suppose if we have this 2px, this will be formed pi 2px, right? And if we have subtraction, right, 2px, right? Now finally we will get node, and this is positive lobe, this is negative lobe, this will be negative and this will be positive, right? Positive, negative, negative, positive, right? And this is node, and this will be pi star 2px, right? So remember this, how the combination takes place. Now what are the conditions for the combination of atomic orbitals? So first condition is energies of atomic orbitals involved should not differ much from one another in energies, right? And second condition is the atomic orbitals combine only if they overlap to considerable extent, right? The atomic orbitals combine only if they overlap to considerable extent, right? And third condition is the combining atomic orbital should have same symmetry about the internuclear axis. इंटरन्यूक्लियर एक्सिस के आसपास जो है सिमेट्री सेम होना चाहिए। ये कुछ हमारे पास कंडीशंस हैं फॉर द कॉम्बिनेशन ऑफ एटॉमिक ऑर्बिटल्स, राइट? तो नेक्स्ट वीडियो लेक्चर में हम एनर्जी लेवल डायग्राम के बारे में बात करेंगे, राइट? इस वीडियो में हम यहीं स्टॉप करते हैं। ओके, थैंक यू।